Good morning. For those of you who've been following our podcasts this week, you will see that I am not Professor St John Green, the Pro Vice Chancellor for Research and Enterprise. I am, in fact, Matthew Guest. I'm the Head of Local and Regional Business Engagement at the University of Lancashire. And I'm going to be your guest host today. And yes, the pun is intended. So, welcome to the final episode in our podcast series for the Research and Knowledge Exchange Festival. We've had a fantastic week so far, and I am delighted this morning to be joined by some guests who we'll hear from in a moment. The podcasts, though, have been to showcase some of the latest research, innovations, and practices from across the Research and Knowledge Exchange community, and they're themed around transforming lives and creating prosperity for Lancashire, the UK, and beyond. As it's the final day of the festival, I'm delighted to be joined by a full panel of colleagues from the School of Engineering and Computing, and they're just going to go around and introduce themselves.
Hi, I'm Professor Georgina Harris. I'm the Dean of the School of Engineering and Computing.
Welcome.
Dr. Hadley Brooks. I'm a Senior Lecturer of Manufacturing and Head of the Additive Manufacturing Lab.
Hi, I'm Professor Bogdan Matuszewski. I'm Professor of Computer Vision. I'm also heading the research group in Computer Vision and Machine Learning, and I'm also Deputy Director of Institute for Engineering and Technology Innovation.
Welcome.
Hi, I'm Dr. Ali Ghanbari, Senior Lecturer in Mechanical Engineering, and I'm the PI for EPSRC grant on future drug delivery.
Wonderful, and welcome as well. And thank you again for coming along today. So we're here today to discuss some of the great work that's taking place around the theme of advanced engineering and manufacturing. I'm going to start, Georgina, to kick things off today. So you've been with us for around a year or so now. Can you tell us a bit about your journey before you joined us?
Yeah, absolutely. So I'm a proud academic in engineering, and I'm also a chartered engineer. I've always maintained that link between industry and academia. It's the excitement and the speed of industry with the rigor of academia, and that split for me is really important. I hold a master's degree in engineering, an engineering doctorate, and a master in business administration. So as you can see, I've kind of trodden the boards between the two quite a bit. I've always worked on multidisciplinary projects. I find them really exciting and interesting because you get to learn something completely new, things outside of your own discipline that you wouldn't otherwise get the opportunity to learn. So I've worked on emission reduction technologies from diesel engines, development of flexural hinges for synchrotron, a synchrotron in Switzerland. I've redeveloped crank axle for a steam locomotive. I've worked on the Square Kilometre Array project, which is a huge international radio telescope looking at brand new digital radio telescopes. And then I moved into an academic leadership role. And then it got even more busy. So you're working with lots of industrialists on student projects, bringing those live briefs into the classroom and making all that new technology real for the students, which is really important for us. I'm currently the president of the Engineering Professors Council, and I'm also the chair of the Greater Manchester area of the IMechE. So I'm looking after both the academic environment, making sure that academics across the country have the things that they need, and also trying to support the local community with engineering, new tools, new techniques. And it's a great way of learning new things by talking to people and finding out what they're doing in industry. My main aim is to try and give people the opportunity to enjoy the discipline that I love and that's given me lots of opportunities. I've travelled all over the world. I've flown planes. I've driven 4x4s across deserts that nobody's walked on for 3,000 years. I've fired and driven a steam locomotive, and I also get to meet the brightest, the best, and the odd famous person. So that's what I think I bring to the discipline. And I'm loving my new post. I'm loving my new colleagues. There's still loads to learn, and I'm really enjoying it.
That's fantastic. That's a really varied background as well that's in there. I love the fact that you've had steam locomotives in deserts that people haven't walked on before. You'll have to just say a bit more about the desert project, I think, there.
So the Square Kilometre Array project it's a big multinational project based out at Jodrell Bank Observatory, and it was to develop initially the first digital radio telescope ever created. So most of them are analog, They effectively look like a equivalent of an analog camera. So instead of now looking at one very large pixel, we're trying to put lots of little pixels together and digitally produce a picture from those little pixels. So quite an exciting project. And we did so well with that then that I got moved on to the international project, working across the globe with the international teams, going to the sites, looking at how suitable they were to host a telescope, meeting all sorts of exotic wildlife that I probably don't want to meet again, and testing for how much radio noise was in those spaces, and whether we had the power provision for the telescope. So these are areas that local communities don't have power. So it's a science project, but it also becomes quite a big corporate social responsibility project that's also got technology projects that hang off. So these are fantastic projects. And as I said, you can't help but learn something new every day because there's always the next thing to worry about.
Yes, and it's not only a science project, it's very much an engineering project as well.
Exactly.
And it probably actually leads nicely onto one of the things I wanted to hear a bit more about is what's surprising you about the work that the University of Lancashire is doing around advanced engineering and manufacturing?
So I think we've got some fantastic facilities and some very varied projects ongoing within the school and the university more widely. I think the thing that I'm surprised by, and that's really quite exciting, is the multidisciplinary nature of all the projects that we've got going on. That makes it really more interesting and a little bit more exotic. So, engineering in medical contexts, engineering in that interdisciplinary space between engineering and computing or engineering and coding. We really do have some fantastic facilities and fantastic multidisciplinary projects. And for me, not every university takes advantage of the ability to work between the different schools and between the different disciplines. And that's something that's really strong here. It's really exciting. And the opportunity to bring those new technologies into those different spaces obviously is going to create something new. And that's always going to be the fun part of the job.
It is, and it's something I've noticed very much when I've been here. Is just each day I discover something new and find out another new thing that's taking place. Thank you. We're now going to move on and have a bit of a discussion with our other panelists today, and to get into a bit more detail around some of the fantastic research and wider knowledge exchange that's taking place. So just to give you a bit of chance to each talk in turn a little bit more about what you're doing. Can you give an example of just one thing, I think for the moment, that you're working on, and just say a bit more about it? And Bogdan, would you like to kick us off?
Yeah, sure. So it is actually quite difficult to only identify a single topic because in our lab we are kind of doing all sorts of different things, starting from health and kind of security and defense, finishing. But the one which is relatively new and we are investing quite a bit in this is in polyp detection in colonoscopy and colon endoscopy as well. This is essentially a way of detecting, segmenting and characterizing polyps in video. And essentially this is to support clinician in the kind of a standard process they have in colonoscopy where they look at the colon and trying to identify polyps, which then they make decision about this, should this polyp be removed or not. And with the help of techniques we are developing, we identify these polyps for them. So they don't, well, they should, but as it happens, they may not always pay this much attention because, they get tired. And therefore, there is a system which kind of looks over the shoulder and helps them in identifying if something they missed, for example, or identifying, say, okay, look at this, check this because this might be something suspicious. The other aspect of this is actually we also help them with vision-based classification of polyps without any biopsy, trying to predict how possible is it possible that it would evolve into the cancer. Remember, no biopsy is just purely optical classification. Other aspect of this is that we kind of try to identify things which they completely missed, not because they didn't pay attention, but it wasn't actually in the field of view because it was hidden behind other structures. So having this kind of a technology opens completely new aspects because essentially we tell them during the procedure that they need to check something. Otherwise, they wouldn't do it because they would not be aware that something was missed, not actually seen, not identified, just not seen. This can be further extended into like assistant, AI assistant, which would be essentially sitting there all the time and helping with advice on where they should go next, what they should do next. Did they follow the exact procedure they're supposed to follow? And we can end up with writing reports. So they actually don't have to waste time on typing. It is going to be typed for them, and information would be included. This may include images from the colonoscope to identify and provide the evidence for further investigations.
Wow, that sounds pretty.
In part, this is already happening. So it's not like we are starting from zero. So there are already a number of commercial products which do in part of all of this, what I said. The detection is relatively standard now. This is available through commercial products.
And it sounds like you're sort of making those advances.
Yeah, well, we try.
Brilliant. Maybe, Hadley, you'd like to add a little bit about what you're working on?
Mm-hmm. So if I had to choose one, it'd probably be, the project closest to my heart would be what I'm working on with my PhD students at the moment. And this is trying to make 3D printing systems more intelligent. At the moment, people might be quite surprised to realize that 3D printers are actually very, very dumb. Mechanical machines, they're not thinking in any way, and they make a lot of mistakes that the machine itself isn't aware of. This causes a waste of materials, waste of time, ultimately a waste of money. And the failure rates are surprisingly high. We're talking 13%, even up to 50%, depending on the machine and the operator, if they're low experience, for example. So this is a barrier for use for a lot of companies. It makes the per part cost way too high. And so this is what we're tackling. So adding intelligence, some sensing. It might be a camera, it might be strain gauges, some other things to the printers, so that they can identify when the printers go wrong. And that's the first step. That's actually the easiest step. And then the next step is, okay, if something's going wrong, and if we can catch it in real time, how do we fix it? There are certain actions that a experienced technician might be able to take during a print to save it if they see that something's going a bit wrong. And we want the machine itself to be adopting those behaviors and making those corrections, which is much, much more challenging than what is currently kind of the state of the art of detecting the thing going wrong at the first place. Yeah. So that would be my favorite.
Can I kind of notice something? It's quite interesting because we are working to help clinicians to remove things, and you are working using also AI to add stuff to material, to build something, whereas we removing something which shouldn't be there.
Yeah. I think the AI machine learning link is probably the thread's going to go through a lot
universal,
of what we're doing now. Yeah.
Probably works quite well to hear a bit more from Ali.
Yeah, sure. If I want to choose one topic, it's the system that we are building now for. Actually, for the first time, we are making a biohybrid microrobotic system for biomedical applications. So what we're doing, we have an artificial microrobot fabricated using 3D laser lithography and coated with nickel to provide magnetic actuation. So we control the microrobot from outside and then have bacteria to follow the microbot using chemotactic responses to follow the microbot and deliver medicine. So that's the whole system that we are developing as the research funded by the EPSRC. So it is, as Georgina said, interdisciplinary project research, and it has magnetic actuation, control, microfabrication, biomedical science, all the disciplines involved. And that's, as I said, that's for the first time we're developing that system, as a new method to deliver medicine inside the body. But it has some byproducts. So we're developing a magnet actuation system, which enables us to wirelessly control the microbot. And also, we are developing some new designs for the microbots to enable to functionalize the microbot to, to fit some chemical substance inside the micro to trigger the bacteria to follow it. And also control strategies, electronics, everything is involved in that project.
Wow. I can remember, I think you showing me a demonstration at one point of this, and I was a bit like, oh my goodness, I can't believe that we're working on this sort of work. It's really interesting.
Yeah,
and it probably leads into actually a question for everyone, is really thinking about what are you seeing in your wider research fields that's particularly exciting you at the moment?
For me, it's the integration of AI into, it's coming into all aspects now of manufacturing. These larger language models can be used directly for some pretty interesting things in terms of operations management, analyzing files, organization, or something that like I'm interested in, which is developing a 3D print farm at the university. But also using the LLMs then to create code and tools that allow you to go on to do other things. So we're starting to see a lot of that, a lot of the barriers to entry in knowing, being an expert coder, for example. Those walls are starting to come down. So people that have needs, researchers like myself, actually, who have ideas, things that we can do with software, but may have been limited in the ability to create that software. It's all becoming possible now, and so that's probably the most exciting thing for me at the moment.
Yes, I would agree. AI is great enabler. So it is really enabling us to do things which were really hard before. We're not really necessarily creative in the sense that writing piece of code could be difficult, but it's just translating the idea. So the creation is in the idea, not actually translating that idea into the code. And therefore, an AI can take this burden and make it easy.
And the speed of development and iteration.
And then you can have multiple versions. I would only say that, and this is, I'm not saying anything new here, that there is also a risk with AI because they can hallucinate. We can trust it too much. There is de-skilling as well. All of this is true. And because I work with AI and I developing techniques, it's not just using, but also developing. So I see all the benefits, but also all the limitations, which, I'm optimist. So I would hope that these limitations would be less and less. For me, it is also linked to AI, but I say it's something like, this is actually a proper term, but I like to think that I invented the term. Cognitive aware AI. So this is essentially a human in the loop. So rather than being just a consumer of information from the AI, you are being a part of making that decision. And it has the significant consequences on how it is actually done. It's not just how we arrange things around. It is about how this AI is trained and delivered. So it is very profound methodology to work on, and people are working on this as we speak, and I think this would eventually bring. I'm not saying that AI is not acceptable. It is. Everyone is using it, but there are also, there are some voices which says maybe we shouldn't rely on this much. But if we are kind of more integrated with this, better understand, because we are in the loop, and AI could adopt to our own needs and expectation and knowledge. So I think this is very exciting, what is happening now in that area.
Wonderful. Did you want to add anything as well?
Yeah, sure. So for me, what's really exciting at the moment is how quickly microrobotics is moving from beautiful, lab demonstrations towards, reliable, clinically systems, or clinically reliable systems that genuinely looks like, very clinically relevant and reliable. There are recently the microrobotics has progressed in the past 2 decades a lot, but in the recent demonstration by many research groups, there are examples of magnetic microrobots. They can navigate through realistic vascular environments that resemble the body very closely, and they're coming together different fields like a smart magnetic control, real-time imaging, AI techniques, biodegradable materials, and as well, biomedicine. They are all coming together. These are all pieces of all pieces that they can impress, but when they come together and they start to create really coherent pathway towards clinical use, that makes me very excited. And that we are passing that threshold from the proof of concepts to clinically use systems that can rely on medicine and potentially revolutionize the medicine. Yeah.
Wow. Thank you. And thank you all for some of those reflections. Georgina, did you want to reflect a little bit more on what you've been hearing as well?
Yeah, I think for me, the exciting element here is the technology convergence. So there's new techniques, new technologies, new manufacturing methods. They might have been designed and developed for a particular application, but the take-up now is so rapid that all the industries are looking at those new techniques, those new tools, those new manufacturing methods, and saying, what can we do with that? So, your fully tailored healthcare support package might look very different from something we had historically. It might be cheaper, might be more effective, might do you less harm whilst giving the medicines into your body, for example. But talking to industrial colleagues, industrialists, what you find is that you're talking to them about these new technologies, and actually it's the same technologies. They're mapping the same new tools, techniques, manufacturing methods as the other companies from a totally different discipline. So that convergence for me is very exciting. That means we're making advances in these things very, very quickly. Better understanding of what they are, what they can do, what they can't do, how we connect those technologies together and make something new. And we're kind of on the cusp of the mass customization era, which is quite exciting. This idea that everybody can have the thing that is just for them. That's a really exciting new frontier for engineering, manufacturing, and engineering more broadly. So for me, it's that animated dialogue with companies, with researchers, and even with the students, thinking about the next thing that perhaps was on a Marvel film, or back in my day, it was something on Star Trek. We can make it, we can build it, we can test it, we can use it. What can we do next? That's the exciting part of the new technologies development.
If I can just add something to it, I think is you're absolutely right. But I think, and I'm not exactly sure why, but it also collaboration in between different disciplines has opened as well. So I found myself talking on a kind of easier terms with clinicians. I've been talking to them for 20 years, but it seems to me that somehow they managed to kind of level the understanding of a technology, and it's easier to talk to them. And is other discipline as well, because I think there's kind of a transdisciplinary aspects of research is really getting hold of, because we were talking about this for a long time, and we should do the interdisciplinary research, we should collaborate, and we did. But I think something has happened, and it may be that the easy access to information help this cross communication is much easier to do this now.
And I mean, I think that's something that the conversation we've had today, this morning, has really re-emphasized, is just how much these little bits of different, what were quite discrete research disciplines, are coming together in all of your work together. Thank you so much. Thank you again to Georgina, to Bogdan, to Ali, and to Hadley for joining me this morning. There's a lot more going on as well on the last day of the festival today. You can in fact see Hadley later on demonstrating some large-scale robotic 3D printing. And please do remember to join us for the announcements of the Dragon's Den and the postgraduate research presentations and the poster winners at 2 p.m. in Foster Lecture Theatre 4. Thank you very much again, everyone.
Thank you.
Thank you.